You know what? There is a nuclear fuel that sounds almost too good to be true. It is called thorium. People say it is safer than uranium. They say it could create less long-lasting nuclear waste. They say it is harder to turn into nuclear weapons. And they say countries like India could use it to unlock decades, maybe even centuries, of clean energy. Recently, thorium is back in the news. China has been testing it. India has built part of its long nuclear roadmap around it. Online, it is often called the nuclear fuel of the future. But here is the real question. If thorium is so promising, why is the world still not running on thorium power? Why are most nuclear reactors still using uranium? And is thorium really the future, or is the hype moving faster than the technology? To understand this, let's dive into it. Here, right now. Thorium is not a ready-made nuclear fuel in the way many people imagine. Most thorium found in nature is thorium-232. It is called fertile material, not fissile material. That difference matters. A fissile material can split and release energy in a nuclear chain reaction. Uranium-235 can do this, which is one reason uranium became the main fuel in nuclear power. Thorium-232 cannot do that directly. First, it has to absorb a neutron. After a series of nuclear changes, it becomes uranium-233. And uranium-233 is the material that can actually split and release energy. So thorium is not the fuel at the beginning of the story. It is more like a raw ingredient that can become useful nuclear fuel, but only inside the right kind of reactor system. And this is where the hype starts meeting reality. Thorium has real advantages, but those advantages depend on building an entire fuel cycle around it. A nuclear fuel cycle is not just one reactor. It includes mining, processing, fuel fabrication, reactor design, used fuel handling, reprocessing, waste management, safety systems, regulations, and cost. In other words, thorium is not just a different rock. It needs a different nuclear ecosystem. That is why the story has taken so long. Now, look at India. India has one of the world's most famous thorium plants because it has long had limited, easy-to-use uranium resources, but much larger thorium potential, especially in monazite sands. Its three-stage nuclear program uses uranium first, then fast breeder reactors, and finally aims to use thorium by converting thorium-232 into uranium-233. That is why India's prototype fast breeder reactor at Kalpakkam, reaching first criticality in April 2026, mattered. It was not thorium power yet, but it was a major step on the bridge toward that long-term thorium goal. Now look at China. China has been testing thorium through molten salt reactor research, where nuclear fuel can be dissolved in hot liquid salt instead of being used only as solid fuel rods. In 2025, Chinese researchers reported thorium to uranium fuel conversion in a thorium molten salt reactor, which is an important experimental milestone. But notice the word experimental. A research milestone is not the same as a commercial energy revolution. A small reactor, proving a concept does not mean millions of homes are about to run on thorium next year. This is the difference between a breakthrough and a rollout. A breakthrough proves something may be possible. A rollout proves it can be built safely, affordably, repeatedly, and at scale. And nuclear energy is one of the hardest technologies in the world to scale. Every reactor must deal with safety, materials, corrosion, radioactive waste, security, regulations, financing, construction timelines, and public trust. Thorium does not magically remove all of that. So why are people still excited? Because thorium does have genuine promise. First, thorium is more widely available in many parts of the world. Second, a thorium fuel cycle can potentially produce fewer long-lived transuranic elements compared with some uranium-plutonium cycles, depending on the reactor and reprocessing design. Third, some thorium molten salt reactor concepts could have attractive safety features, including low-pressure operation and high-temperature efficiency. Fourth, countries with thorium resources see it as a possible path to long-term energy independence. And finally, thorium has a powerful story. It feels like the underdog fuel. Uranium became the main road of nuclear power. Thorium stayed in the background. So every few years, when a new experiment succeeds, people ask the same question again. Did we ignore the better fuel? The honest answer is more complicated. Thorium was not ignored only because people made a bad choice. Uranium reactors became dominant because uranium technology was ready earlier. It had military history behind it, fuel supply chains, reactor experience, industrial investment, and decades of operating knowledge. Once the world built thousands of systems around uranium, switching became difficult. Energy systems do not change just because a better idea appears on paper. They change when that idea becomes proven, approved, reliable, economical, and easier to build than the system already in place. Thorium has not fully crossed that line yet. That does not mean thorium is fake. It means thorium is promising, but not simple. It is not a miracle fuel waiting for someone to flip a switch. It is a long-term nuclear technology that still needs engineering progress, commercial proof, fuel cycle development, regulatory confidence, and public acceptance. So is the hype worth it? Yes, but only if we understand what the hype should actually be. The hype should not be, thorium will replace uranium tomorrow. That is unrealistic. The better message is this. Thorium could become an important part of future nuclear energy, especially for countries that build the right technology around it. And that matters because the world needs reliable, clean electricity. Not only when the sun shines, not only when the wind blows, but all the time. Cities need power. Factories need power. Data centers need power. Electric vehicles need power. Homes and hospitals need steady energy. Solar and wind are growing fast, but they need storage and stronger grids. Fossil fuels still provide huge amounts of power, but they also create pollution and emissions. Nuclear power offers steady low-carbon electricity, but it comes with cost, safety, waste, and trust challenges. Thorium enters this debate as a possible improvement, not a perfect escape. That is the best way to see it. Not as magic, not as a shortcut, but as a serious and difficult possibility. If thorium works at scale, it could help some countries use domestic resources, reduce dependence on imported fuel, and build a cleaner long-term energy mix. But until thorium reactors are commercially proven, widely licensed, economically competitive, and safely operated over time, thorium remains more promise than power. So the next time you hear someone say thorium is the future of nuclear energy, do not dismiss it. But do not believe the miracle version either. The real story is more interesting. Thorium is not the fuel that saves the world tomorrow. It is the fuel that still has to prove it can help power the world someday. And you know what? Sometimes the future is not hidden because nobody found it. Sometimes it is hidden because it is difficult to build. If this made you think for a second, like, share, and subscribe. Because there is a lot more hiding in plain sight.